Hey guys, how are we this evening? So, we've been working with systems of equations, and we've been working with systems of linear inequalities, and we've been working on solving them. We also worked on word problems dealing with systems of equations. Now we're going to get to there's actually two different types of systems of equation word problems that we're going to deal with here, and I'm going to do an example of each one. Just to give you guys a heads up on how to do them. You'll expect to see these tomorrow, and Thursday I'm probably going to do a little bit of systems review where you're going to see some word problems, you're going to see some just equations and solving them. And I'm even probably on Friday, I might even have you guys work on coming up with your own systems of equation word problems. And then we'll pass them along and have another group actually work on solving them. Tonight we're going to be working with what we call distance and mixture problems. Now there's a method to the madness here when you're working with distance and mixture problems. So let's go ahead and look at the first one, which is going to be a distance problem. Now, there is a formula that goes with a distance problem. It is distance equals the rate times the time. Okay, and you can actually make yourself a little chart if you wanted, which would make things actually significantly easier. So I'm going to go ahead and do one real quick. And with a distance chart, you're going to have three problems because you're going to have it set up just like the equation that you have there, distance equals rate times time. And we're going to have the d here, this is the rate, and this is the time. Okay, and now we're going to go ahead and we're going to set up our word problem. Alright, so it says a ship left the pier and traveled north at an average speed of 20 miles per hour. So we're going to call this ship 1, and this is going to be, well actually, once we finish reading the problem, this is actually going to be an aircraft carrier, so we're just going to leave it as ship 1. And it travels at 20 miles per hour. Well, 20 miles per hour should be a dead giveaway. This is going to be our rate. Anytime a rate is something, it's a unit per another unit. So miles per gallon, miles per hour, feet per second. All that stuff is going to be what we would call the rate. And it says an aircraft carrier, so I'm just going to put this as AC, left sometime later, traveling in the opposite direction with an average speed of 20 miles per hour. So now we have the rate of our second ship. After the container ship had traveled 11 hours, so that gives us our time. This is going to be 11 hours. The ships were 440 miles apart. How long did the aircraft carrier travel? So I know my first distance is here, and my second distance is this. Now, it did not give us a time that the second ship traveled. Matter of fact, that's what it asked. How long did the aircraft carrier travel? So I'm going to put a T in my chart. Okay? So now let's go ahead and set up our two equations. We have D1 equals 20 times 11. And then you have D2 equals 20 times T. Now there's one other very important piece of information that we have here. It says that the two ships traveled and they were 440 miles apart. So if we draw a picture here, okay, actually let me make this picture a little bit neater. So we got a distance here, and let's say that, just for starters, both ships, it's assumed that they start in the same place. based on the fact that it doesn't specify that they're starting in a different place. So we're going to put a line here. Okay, so ship 1 leaves from here, and then let's say it travels north. Okay, so this is going to be our D1 from this line to this line. Now from this line to this line is going to be our D2. And we know that from here to here, where they stop, it is 440 miles. So you should be able to see that D2 plus D1 is going to equal the entire 440 miles. Okay. So let's go ahead and do this now. D1 then will equal 20 times 11. Okay, 1 times 0 is 0, 1 times 2 is 2, and then we're going to bring down the 0. 1 times 0 is 0, and 1 times, oh, here, let me just write it so that you can see it, because I'm actually getting confused just trying to talk about it. So this is 0, this is 2, bring down the 0, this is 0 and 2, which means this is going to be 220. Okay, so our first distance then is 220 miles. So if I plug this in here, I've got D2 plus 220 equals 440. Now if I solve for D2, that means that D2 is going to be 220 miles as well. So I will plug 220 in here, and now I'm going to solve for T. So I'll divide by 20, and I'm going to get T equals 11. Okay? And that gives me the time. So that tells me that the aircraft carrier then traveled for 11 hours as well. So it just so happens to work out that the first ship traveled the same distance as the second ship. But this would be how you do it, regardless of how long or how fast each ship travels, all that information. Okay? Now we're going to get to our mixture problems. And this is going to be done similar to what we just did. You're going to want to do a chart. And that would be why it was not working. Alright, let's fix this. Okay, so this is going to be using a chart. And when we do this, you're going to have 3 rows, and you're going to have 3 columns this time. Okay, the first one, let me see if I can move this up so I got a little bit more space to write. Okay, so the first one is going to be your the amount of whatever you're working with. Okay, this is going to be your percentage, and this is going to be the amount of so for example, let's read the problem first. So we have 3 liters of 50% saline solution. So this is going to be the percent saline, and this is going to be the amount of saline. So the percentage is talking about if you have 3 liters and it's 50% saline, then that means that 1.5 liters is saline, 1.5 is probably going to be some other type of liquid like water. Okay, so when you're talking about the amount, this is the total amount of the solution. This is the percentage of whatever you're dealing with, and then this is the amount of that same item. Okay, so we're going to call this solution 1. This is going to be solution 2. And then this one down here is going to be the combination. So when I put these 2 together, this will be what I get down here. Okay, so the amount, let's read through this. So 3 liters of 50% saline solution. So this is 3 liters. This is 50%. Okay, and now this is how we find this. This is going to be this box, and I'm going to actually do this in red. So it'll be the first box times the second box equals the third box. So this would be 3 times 50% or 0.5. Now it says was mixed with 12 liters. So this is 12 liters. of 10% solution. Now the other thing I want you to get used to is instead of writing these as percentages, you guys should all know how to convert a percentage to a decimal. So this would be 0.5, this would be 0.1. So we're going to do the same thing. It's multiplying these two equals. So this is 12 times 0.1. And it says find the concentration of the new one. Well, very simply, combination. If I have 3 liters of solution 1 and 12 liters of solution 2 and I'm going to put them together, that means I'm going to do 3 liters plus 12 liters equals, so that's going to be 15 liters. Find the concentration, which means I'm looking for the percentage. We don't know this, so I'm going to replace this with an X. And then this is going to be the same. So this one was this times this equals this. This is going to be this box times this box equals this box. So that's going to be 15 times X. Now, we fill in these boxes to get these individual boxes because now we're going to do the same thing. It's going to be this box plus this box equals the bottom box. So I get my equation, and that is 3 times 0.5 plus 12 times 0.1 equals 15x. So now I'm going to very simply, I'm going to simplify this side and solve for x. Now, nobody likes working with decimals, so we're going to get rid of the decimals. In order to get rid of the decimals, I need to move this decimal one place to the right and this one place to the right, which means I can multiply everything in here by 10 and get rid of my decimal. Okay? So when I'm multiplying across multiplication, so this is 3 times 0.5, I only multiply this to one of the numbers. So I'm going to have 3 times 0.5 will become 5 plus 12 times 0.1 will become 1 equals, and 15, you have to multiply one of these by 10, so that's going to be 15 times 10 is 150x. Now you're going to do the multiplication and you're going to solve for x. So 3 times 5 is 15 plus 12 times 1 is 12 equals 150x. This is going to be 27 equals 150x. And now you're going to divide this by 150 and this by 150. Okay? So you're going to get x equals, and you could do long division to do this, but this new found Common Core stuff that they want us to do encourages calculator use. So there is nothing wrong with you pulling out a calculator and doing 27 divided by 150, which is going to give you the decimal x equals 0.18. Okay? And now we need to turn this to a percentage because it asks us what concentration of the new is, find the concentration of the new mixture. So we need to turn this to a percentage, which means I'm going to multiply it by 100, which means that my new mixture the combination is going to be 18% saline solution. And that's really all there is to mixture problems. So if you can remember the setup for the box and the arithmetic that goes in between the boxes, then these are actually fairly easy problems. Be ready to do some of these tomorrow when you guys come into class. I hope you guys have a great night tonight, and we will catch you guys tomorrow.